9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
What if you woke up one day and discovered that everything you've always taken for granted is not what it seems at all? What you thought was reality is actually a simulation, a very complex, sophisticated illusion that you live inside of. Even solid matter itself is no more real than, say, a rock that you would pick up in a dream. And not only are you living in a simulation, but it's being generated by a system that you can contact with your mind and actually change the simulation itself, in effect, hacking the universe. What would you do to change the world? Well, recent scientific discoveries are strongly suggesting that this is the case, that we live inside a simulation, and that we, as observers, have a demonstrable power over it. We are actually participating in the creation of the reality that we live in. Wait, what? Are we really living in a simulation? Well, this is the conclusion that physicists and cosmologists have been coming to. And although this idea would have been ridiculed in the recent past, it is now being taken very seriously. Cutting-edge physics experiments have been producing some very strange results. Results that say our universe isn't an objective reality, but that it's actually emerging from something else, something non-physical and beyond our senses. In the digital age, science is beginning to see a correlation between our world and the world of a virtual reality. By following this logic, you come to believe that consciousness is primary and gives rise to all physical matter and process. In other words, everything begins with consciousness, and there is a mind behind what we experience as physical matter. In much the same way that when you dream, your mind is creating a physical experience for you while you sleep. As you can see, these philosophies are mutually exclusive, and are in fact opposites. Both cannot be true. Either mind gives rise to matter, or matter gives rise to mind. It's a very, very old debate, but science has finally harnessed enough power to settle it once and for all. The analysis starts at the beginning, with the Big Bang. This well-established cosmological model demonstrates that space-time was created by a single event billions of years ago and expanded into what we see around us today. Nearly all scientists agree that our universe began to exist at one point in the distant past. From the materialist view that our universe is all there is, as an objective, independent reality, the fact that the Big Bang came from nothing is very hard to explain. How could everything come from nothing? Another thing to consider is quantum bits. The fact that light is quantized as photons, electricity as electrons, etc. better fits the hypothesis that we live in a virtual construct. Because in digital processing, all data must have a minimal quantity represented by bits or pixels, and our world displays the same property. Every computer-generated image breaks down into pixels when examined closely, and this is what science has found in nature. In the past century, physicists have discovered that matter really is quantized, composed of fundamental, indivisible particles billions of times smaller than an atom. And, as science has discovered more and more about the way the universe behaves, it has become clear that nature is a matrix of computable bits. Space is quantized, time is quantized, energy is quantized. Everything is made of individual bits, which means the universe has a finite number of components, which means it has a finite number of states, which means it's computable. Okay, for the sake of argument, let's say the data does fit the simulation hypothesis better than it fits materialism. That's all well and good. But is there any solid evidence of computer programming in nature? It seems there is. Theoretical physicist James Gates has actually found computer code hidden deeply in the equations that describe supersymmetry.
So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
Into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code, you're saying it is computer code.
It's not even just is computer code, it's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s. Every digital symbol created by the same program is identical to every other in the same class. In computing terms, objects are simply instances of a general class. The fact that all quantum objects are identical in each class, photon, electron, etc., correlates to a digital equivalent, since in a virtual world, every digital object created by the same code is identical. While the objects we see in our world have individual properties, the quantum bits that they are built from are all pressed from identical molds. The simulation hypothesis suggests that this is the case because each bit is created by the same program. Taken together, all of this might constitute what the courts refer to as sufficient weight of evidence, favoring idealism in the simulation hypothesis over materialism. When coincidences continue to pile up and combine with explanatory power, it presents a very strong plausibility argument, or even a proof. But even more convincing evidence is provided by cases that the simulation hypothesis can easily explain, but which materialist models have tremendous difficulty with. One such case is non-locality. Materialism to be true, and the world to exist independently of mind, the concept of locality is necessary. This means that for objects to interact, they must be in close proximity. This is what Albert Einstein believed for most of his life. Well, it's the 1920s and every young boy wants to be Charlie Chaplin. This one wanted to be a scientist. His name is Werner Heisenberg. You may be familiar with his famous uncertainty principle, which sets hard limits on empirical inquiry. In 1925, he introduced a concept known as matrix mechanics in an attempt to explain how energy is absorbed by atoms. He did this by describing atoms not as actual physical objects, but as mathematical matrices that evolve over time. Matrix mechanics was very radical stuff, and it didn't look like traditional physics at all. Niels Bohr accepted Heisenberg's ideas as valid, but most other physicists, including Einstein, thought of them as something of a fad that would fade away once a better theory was found. Heisenberg became a professor himself and started to spread his own ideas. This is Erwin Schrödinger. In 1926, he was teaching physics at the University of Zurich, where Einstein had gotten his PhD. He wrote a paper introducing wave mechanics as an alternative to Heisenberg's matrix mechanics. It was Schrödinger who first claimed that two particles could be entangled and that they would behave as one system, as one thing, mind you, even if they were separated in space. This meant that any interaction with, observation, or measurement of one of the entangled particles would cause an instantaneous effect in the other, even at great distances across space, up to and including infinite distance in space. This is what is known as non-locality. For the majority of physicists, who were, after all, completely invested in a materialist view of the universe, this was truly unacceptable, and simply could not be true, even if all the equations worked. They just needed to put their heads together and figure out what was really going on with this newfangled wave and matrix mechanics. Einstein took particular interest in this problem because it was he who had let the genie out of the bottle with his photon and the quantum theory of light. By 1955, Einstein was an elderly man. He had been working on his unified field theory for 28 years to no avail. This was the man who had written 4 groundbreaking scientific papers in a single year. He had explained why the sky is blue, what makes the sun shine, how acceleration through space can slow down time. He overturned Newton's theory of gravity, and many, many more accomplishments. But now he had spent nearly 3 decades trying to salvage materialism, and was unable to do so. Albert Einstein passed away on April 18, 1955. In 1962, Niels Bohr died, his conflict with Einstein still unresolved. Then, in 1964, the Irish physicist John Bell proposed his famous theorem. It's a very clever mathematically based way of experimentally testing and proving one way or the other who was right. Doing the experiment would require some very special hardware. It took 18 years for this technology to become available, and in 1982 the physicist Alan Aspect put it all together and ran the experiment. The results confirmed that non-locality was actually real. What Schrödinger had called entanglement, and was defended by Bohr but ridiculed by Einstein, was a fundamental property of nature. Instant correspondence can be seen between 2 particles that are separated by unlimited distance in space, and this only makes sense if the world is a virtual construct. Prior to observation, matter does not seem to exist. Matter seems to be the result of an interaction between consciousness and waves of potential. This has been demonstrated repeatedly in ever more precise versions of the double-slit experiment, from the 1920s right up through the present.
Consciousness is information. It's an information field. Okay? It's data.
In 1978, physicist John Wheeler proposed a new way of doing the double-slit experiment that might finally reveal what's really happening. He proposed what is called the delayed choice experiment, in which the decision of whether or not to observe the particles isn't made until after they've gone through the slits, but before they've impacted the detector. This animation is highly simplified, but you get the idea. Here comes the light. It travels through the double-slit barrier as waves. The waves are past the slits but haven't yet hit the detector. And here comes the scientist. His eyes are closed. He's delaying his choice to make this an observed experiment. And then... The results of the experiment didn't solve the mystery. Instead, it got even stranger. Because what was found was that at the moment of decision to observe, the waves became particles. And not only that, but they actually made a record of themselves as having traveled through the slits as particles. Yes, you heard me. Deciding to run the observed experiment causes the waves to become particles, and this causal force extends backwards in time.
Our choice of what experiment to do determines the prior state of the electron.
Running the experiment unobserved does not cause this effect. When John Wheeler first proposed adding the delayed choice protocol to the double-slit experiment, he asked us to imagine a distant star that emits a photon billions of years ago and sends it towards the Earth. However, on the way, it must pass a dense galaxy. Gravitational lensing will make the light bend around the galaxy. Billions of years later, upon reaching the Earth, an astronomer chooses to use a binocular-type detector and focuses half of it on the left side of the galaxy and half of it on the right side. How the astronomer chooses to measure means the photon could only have taken one path and would display a clump pattern. So how we choose to observe in the present, the determines how the photon behaved billions of years ago. What John Wheeler had predicted was confirmed by the experiment. This doesn't make sense in the materialist worldview. It only makes sense if the universe is a simulation and all parts are equidistant in space-time with respect to the source of the simulation, like in a video game or a dream. One of the hottest ideas in cosmology is known as the Holographic Principle. It's the idea that our three-dimensional universe is emerging from 2D information. That is, three-dimensional objects are composed of information spread out on a two-dimensional surface, in the same way that a hologram produces a three-dimensional image from two-dimensional information. The holographic principle tells us something very surprising. It says that our ideas of volume, and in a sense, the world, might be a kind of illusion.
First of all, I would say it should be clear that this whole holographic story is the most radical thing that has happened to our understanding of space, time, matter, since the invention of quantum mechanics and relativity.
Quantum theory in general, and the results of the experiments that have been run in this area, reinforce the holographic principle. Science has decided. Materialism is not a valid worldview. Most physicists now accept that particles do not exist as objects in the absence of observation, but exist only as waves, which then form into particles when observed. These waves aren't anything tangible like ocean waves or even radio waves, but simply a probabilistic description of where the particles might be if they were checked on.
Particles are probability distributions, not little hard things. But when you measure them, like measure which slit they go through, you get a particle.
The wave that forms into a particle is only a wave of potentiality. This is what Werner Heisenberg said many years ago. Reality is all emerging from the same source. So, is the quantum realm different?
No, no different. Only different in your mind. You must unlearn what you have learned.
Okay, fine. So the science says that we may really be living in a simulation. But what does that mean? Am I being kept alive in one of those scary pod things from the Matrix? Is my brain sitting in a jar somewhere with wires hooked up to it? Is someone else in control of my thoughts, feelings, and dreams? Why is all of this so mysterious and difficult to understand? Wouldn't a creator want me to know what's going on? Is the creator afraid to expose their true intentions? Is he hiding from us? Why? Why won't he reveal himself?
Pay no attention to that man behind the curtain!
What if part of your subconscious is still connected to the original consciousness that programmed this virtual reality? After all, we know that our subconscious can create a physical experience for us while we sleep.
Genuine inspiration, right? Now in a dream, our mind continuously does this. We create and perceive our world simultaneously, and our mind does this so well that we don't even know what's happening.
I don't know a single scientist who would disagree with the statement that the world is exceedingly ingenious. Not just mathematical, not just beautiful, not just elegant, but the manifestation of something truly extraordinary.
You've taken your first step into a larger world.